Another day, another vlog. Today, we're covering the fundamentals of structural design, including beams, slabs, and columns. We'll be designing their design process, the pros and cons, and why they are essential in construction.
By the end of this video, you will have a better understanding of how these structural elements work together in order to support buildings. Let's get started. A beam is a horizontal structural element that supports a load and transfers them to columns or walls. It is important to know that beams are crucial in a building in order to prevent them from collapsing. There are different types of beams: simply supported, cantilever, and continuous beams. Each type has its own design considerations.
The design process includes calculating load capacity, material selection, and ensuring proper reinforcement to prevent failure. If a beam is not designed correctly, they can deflect or crack under heavy loads. Let's go through a sample problem to see how we check if a beam meets ACI code requirements.
First, we calculate the maximum reinforcement ratio using the formula. That gives us the maximum reinforcement, but the ACI code requires the minimum reinforcement ratio in order to prevent sudden failure. We check using this. Then we compare the actual steel areas with these values.
If it's too high, it is over-reinforced, which can lead to brittle failure. If it's too low, it's under-reinforced, making the beam unsafe under heavy loads. That's why engineering calculations are so important. They ensure safety and efficiency.
Next up, slabs. A slab is a flat, horizontal surface that forms the floors and ceiling of the building. Slabs distribute the weight of everything above them to the beams and columns. They come in types like one-way, two-way, and waffle slabs. The design process involves determining the thickness, reinforcement details, and load capacity to prevent bending or cracking. But slabs also have their drawbacks. Improper reinforcement or poor quality materials can lead to structural failure like sagging floors or cracks. That's why careful structural design is crucial. Let's break it down step by step for one-way slab, shall we? A one-way slab is supported by beams on two opposite sides, and the load is carried in one direction. We calculate its minimum thickness using this H is equals to L over 24 for simply supported beam. First, we determine the minimum slab thickness to ensure stability before we calculate the weight of the slab and how much load it carries. Then, we solve for the moment using this formula. Design the steel reinforcement and check the bar spacing to maintain structural integrity. With the right calculations and proper reinforcement, we ensure that the slab is strong and safe.
Finally, let's talk about columns. Columns are vertical structural elements that supports beams and slabs, transferring loads to the foundation. There are different types of columns: rectangular, circular, and composite columns serving specific structural needs. The design involves calculating axial loads, selecting the right materials, and ensuring stability against buckling. However, columns have their challenges: inadequate reinforcement or improper alignment, which can lead to structural failure. Here is the sample problem. To prevent that, we designed a squared tight column using this formula. Solving the gross section area, AG, we use a 14-inch by 14-inch column. For reinforcement, AST is equal to 3.62 inch squared, therefore we use 8 number 7 bars. And for the ties, spacing is 14 inch and use number 3 ties at 14 inch. So, that's a quick overview of beams, slabs, and columns.
We covered their functions, design process, and some common challenges in construction.
Understanding these elements is essential in order to have a safe and durable process.
Thanks for watching! Don't forget to like, share, and comment down below if you find this video helpful. See you again next time, guys! Bye!